So, on here, for the review, first off, I think a lot of people miss part of the directions on there. The first part of the directions asks you guys to identify the theorems in which you're using to solve. So, identify the theorem or definition that helps you solve each one of these problems. So, the first thing that we have here, number one, we have an isosceles triangle. We know it's isosceles because it's labeled as isosceles, right? Those two legs are congruent. Now, what theorem do we actually get to use? Well, once we know that these two sides are congruent, we know that the two angles across from them are congruent. So, this angle here is congruent to that angle there, right? Those two angles must be congruent. That is the isosceles triangle theorem. Isosceles triangle theorem. Well, how do we use that? Well, since we know that these two are congruent, we're going to set them equal.
Is there going to be multiple choice?
There are quite a few multiple choice, but there's also free response.
I hate those.
Yeah, you know. Subtract 3 from both sides, the 3x, and you're left with just x equals 18. We already know what x is. So that's our first answer. Now, once you know what that is, we have to take it and plug it back in to find what these angles actually were. So, substitute 18 in for x. 4 times 18 equals 72. So now I know that both of these angles are 72. So now we're going to use triangle sum theorem. Triangle sum theorem to say that all three angles in the triangle have to add up to 180. So I'm going to take the 180. I'm going to subtract off the two angles I know, which are both 72. So 72 and 72. And that gives us a total of 144. So 180 minus 144 is 36. And that's what y is. So again, that's how we found y. Yeah. Now, on the next one, find the value of x. Well, first off, we have this triangle here. Everybody sees that triangle? And then this piece here, this is an exterior angle. That whole thing is an exterior angle to this triangle. So I can take these two pieces and use exterior angle theorem to find that missing piece. So we can say 85 plus 65 equals 150. So this whole thing there is 150. Now that we know that that whole thing is 150, I can use angle addition postulate to say that if this whole thing is 150, subtract the 65, and that leaves us with 82, and that would be x.
What is that? 68?
Now, on this next one, again, we have a triangle here. Based on this triangle, we can use triangle sum theorem. Triangle sum theorem. All three angles have to add up to 180, so we can say 180 equals all three of these added together. So, thank you. Add all three of these together. We have 90 plus, we have those two x values. Let's go ahead and combine those. We have a negative 10. Well, let's go ahead and add 90 and negative 10 together. That would give us 80. Bring the 80 over to the other side. That gives us 100. Whoops, that was an x. I don't know where the 0 came from. Divide by 5. And x is 20. Now that we know what x is, we can take it, plug it back in. We only have to figure out what this top angle is, because now 20 times 3 is 60. So that's the top angle here. These two angles are remote interior to this exterior angle. So now, exterior angle theorem again. We can set these two added together equal to this one. So we have 2y minus 10 equals 90 plus 60. 90 plus 60 is 150. Bring the 10 over. That's 2y equals 160. Divide by 2 and y equals 80. And those are our two answers. Now, on the next diagram, we are given a triangle, and we are shown that we have these two pieces as congruent angles. Well, if we know that those two angles are congruent, what else do we know?
Sides are congruent.
The sides across them are congruent, making this an isosceles triangle. So we just did the converse of isosceles triangle theorem. Converse of isosceles triangle theorem. So now we're able to set these two equal to each other. 4x minus 11 equals 2x plus 3. Subtract the 2x, leaves you with 2x. Add the 11, gives us 15. Wait, nope, 14. A lot. Divide by 2, and x is 7. Now that we know what 7 is, that's not an answer. It doesn't ask for x. It wants to know what the base is. So now that we know what x is, we have to plug it into the base. But we had to find x before we could solve for the base. So 6 times 7 is 42. 42 minus 5 is 37. So 37, that's our base. The other part of this, we're going to use triangle sum theorem to find the vertex, because we have two of the three angles. Triangle sum theorem. All three angles must equal 180. So 180 minus the two angles at the bottom, which are both 65. So minus 130 gives us, whoops, not 150, just 50. And that's it. And that one's in degrees. All right. On the next one, number 5. First thing that we can do there, we got vertical angle. So use vertical angle theorem to say, hey, this one has to be 63. Once you know that one's 63, then you can solve for what they're asking for, because they're not asking us for that angle. They're asking us for u and v. So to solve for u, we have two of the three angles of the triangle, so triangle sum theorem. All three angles must add up to 180, so 180 minus the two angles that we know, 40 plus 63, which is 103. So 180 minus 103 is 77. And that's for u. Then, on the other part of the triangle, we have v. All right, solving for v, we have an exterior angle, so we're using exterior angle theorem. 108. Oops, I just put 180. My bad. 108 equals v plus 63. Subtract off 63, and that leaves us with 45. That's v. Those are our two answers. Number 6. What is the value of y? Well, again, triangle sum theorem. Triangle sum theorem. All three angles must be 180 degrees. So 180 equals, well, this is the same for all three angles. How do we know that? Well, that idea is based off of our idea of isosceles triangle theorem, right? The congruent angles are going to be across from the congruent sides. Well, in this one, it's equilateral. So all the sides are congruent. Therefore, all the angles must then also be equal. But again, it's based off of the idea of isosceles triangle theorem. So I'm going to write that down as well. Isosceles triangle theorem. That's how we're able to label them. So now 180 equals 3 times that 10y. Divide off the 3. Each angle individually is 60. So 60 equals 10y. Divide by 10, and y is 6. That's our answer. I forgot to circle this last one. That doesn't really matter. All right. Going on to the next column. Now, on A, what type of line is that? So this dotted line is what? These two sides are congruent, therefore
Oh,
this
angle
is
bisector.
an angle bisector. Alright, this one,
Perpendicular.
perpendicular bisector. This one would be a median, just median. And then this one is altitude. And that's it. Number 8. What point of concurrency is equidistant to the vertices?
Perpendicular bisector.
No. That's what makes it. Perpendicular bisector is what makes the circumcenter. The circumcenter is the one that's equidistant to the vertices. What point of concurrency is known as the center of gravity?
Oh, God.
Centroid. Again, it's asking for the point of concurrency, not lines. Be careful. What is the point of concurrency of the altitudes? Orthocenter. What point of concurrency is equidistant to the sides? Again, we want the point of concurrency, so in center. So be careful on the wording there. They were asking for the points of concurrency, not what parts would intersect to give you those, but what was the actual point of concurrency. All right, number 12 was a little challenging. You had to think about it a little bit. You could use a couple different properties here. You could go way back to the previous section. Since you know that this is a perpendicular bisector, if they tell you that you have a perpendicular bisector, then every point on that perpendicular bisector has to be equidistant to the endpoints of the segment. So you can mark it like so. Now you know this is an isosceles triangle, and you can set these two congruent. So we have 33x plus 2 equals 35x minus 4. I'd bring the 33 this way. So that'd leave us with just 2x. The 4, bring it across by adding. You get 6 divided by 2, and x is 3. That's all they want us to find.
That was not hard.
On number 13, compare and contrast the radius of a circle inscribed versus a circumscribed in or around a triangle. So what's the difference between the radius for a inscribed circle versus a circumscribed circle? This goes back to the sheet that you had missed. So when we talk about an inscribed circle, the radius goes from the in-center to the side of the triangle. For a circumscribed circle, it goes from the circumcenter to the vertices of the triangle. So what you could say here is, let's see, inscribed radius is shortest distance from in-center to sides of triangle. The circumcenter radius is the distance from circumcenter to vertex of triangle. Oh, I put circumcenter there first. I should have said the circumscribed radius. Circumscribed radius. Alright. Again, inscribed radius is shortest distance from in-center to sides of triangle. Circumscribed radius is the distance from the circumcenter to the vertex of a triangle. Now, in comparison to one another, which one should always be longer? The circumcenters, or the circumscribed circle's radius, right, should be the one that's longest, because if you're going from a point inside the triangle to a side of the triangle, that distance will always be shorter than going all the way to a vertice of the triangle. Yeah. that hard one? No. I already said that. I don't think our test questions on this one are very hard at all. Again, I'm not saying the test is easy. I'm saying that I could have made it 10 times harder. But I went easy on you guys this time. Okay. Again, it's not. I'm not saying it's an easy test though, because you still have lots to remember. All right, on 14, you have mx is 18. That whole thing is 18. Again, this length is 2/3 the overall length. This one is 1/3 the overall length. So if that whole thing is 18, a third of it is 6. 2/3 would be 12. Again, the whole thing is 18. For kW, 10 there. So if the longer piece is 10, this piece is half of that, so this would be 5. ZW, it says, is 4. So if that little piece is 4, this big piece here is double it, 8. Which ones did they ask for? MW. MW we said is 12. WY is 5. And ZL is also 12, because you got to add the 4 and the 8. On 15, what are the coordinates of the centroid? All right, this one was a little challenging, and I'm going to draw a horrible diagram of it.
Oh, I didn't even see that one.
All right. 1, 2, 3, 4, 5. 1, 2, 3, 4. Okay, so in order to make this fit on here, each one of these lines is representing 2 units. All right, so 3, -10. 1, 2, wait. So 3, -10 would be between these two, and all the way down here. 4, 2. I'm going to go out to 4, up to 2, right there. 2, 5. 2, 5. I mean, right about there. So those 3 points form a triangle. It is. Now, drawing in, again, I'm just doing a very rough sketch of this, but approximately halfway on this side would be about there. So I'm going to draw my line there for a median. Approximately the midpoint of this line is right about there, so I'm going to draw a line right there for my median. Now, really, once I have 2 in, do I really have to find the third? No, but you can draw it if you want to. So the median of this side is right about there. So drawn a third line. They all intersect at the same place, which is right on the x-axis at 3. Because I said I made each one of these points 2, right? So this is at the point 3, 0. Now, the one on your test is a little more spread out than that. It is much easier to see, but it's exactly like the question we did in class last week. So again, it will have a graph on there. It'll already have the triangle on there for you. All you have to do is find the midpoint of each side and draw in the medians. Wherever the medians intersect, that's your centroid. Okay, going on to the back. So now, for this one, actually, let me grab a new sheet so this doesn't bleed through, because I'm going to take a picture of this to post it online. So let me do it on a new sheet. Okay, on here, each one of these, you had to identify what type of triangle it was. Now, this one, all different length sides. We have one right angle, so this would be what?
Oh, a right scale.
Right scalene. You should be using at least one word from each blank there, or each box. All right, this one,
Acute scale.
I would call it acute scalene. Some people told me earlier that they thought it looked more like isosceles. I could see an argument. It's close. Those 2 sides are pretty close, but I think that side's longer than this one.
Well, if they were
So,
no, that one right there is
yeah, I would have put the marks if I meant for them to be congruent. All right, on here, equilateral and equal angular. Yep.
Oh.
So, equal
That's annoying.
angular, equal
No.
lateral. Now, if you have an equilateral triangle, it can also be what? isosceles. All equilateral triangles are also isosceles. All equal angular triangles are also
Acute?
acute.
Oh, yeah.
Because if it's equal angular, all of them are 60. Those are all acute angles. So technically, this is all 4. If you had something like on, like say, an FSA test, and it said select all that apply for an equilateral triangle like this, you could select all 4 of those options. All right, kind of a tricky question, but again, all 4 of those work. On 19, this one is
Oh, obtuse. Isosceles.
obtuse and isosceles. Top angle is obtuse, and we have 2 sides marked as congruent, so isosceles. All right, fill in the blanks. Always base, legs, sometimes in vertex are the things that we're filling it in with.
Okay.
The congruent sides of an isosceles triangle are called the, and between them is the vertex angle, which is across from the side called the base, which is between the 2 base angles. An equilateral triangle is always isosceles, but an isosceles triangle is only sometimes equilateral. All right. On the next one, if the triangle is isosceles, then circle all the following that apply to CD. So what is CD out of those 4 things?
Is altitude, median, angle, bisector, perpendicular, bisector?
Yeah, it's all of them. So again, if it's isosceles, again, that line can be all 4 things. All right. So now, number 22. What is true? What is true about the incenter, circumcenter, centroid, and orthocenter of an equilateral triangle? It's all the same point. Again, only happens in an equilateral triangle, but they're all the same point. All right, on number 23. Emily's dad can't decide whether he should build a new McDonald's, where he should build a new McDonald's. There are 3 main roads that go through town, and 1 main place, guys, and 3 main places people go to hang out. Explain why both the incenter and circumcenter would be good choices. So why would the incenter be a good choice?
Because both of them are the same distance from each of the vertices.
But which one is that? Incenter or circumcenter? Circumcenter. All right. Equal distance to the vertices is our circumcenter. Incenter is equal distance to the sides. So on here, what represents the sides? The roads. What represents the vertices? All the hangout locations, right? So we could say incenter equidistant to roads, which I could also say sides. Circumcenter equidistant to hangouts / vertices. All right. Now, what are not good choices? If this was a multiple choice question on the test, what should you not select?
Oh, the actual.
What are the other points of concurrency? Centroid and orthocenter. Centroid and orthocenter, not good places when talking about a question like this. If you're looking for a place that's equal distance to different parts, it's either the centroid or the incenter. Incenter equal distance to vertices, circumcenter equal distance to... Wait, did I just say that backwards?
Yes.
Incenter equal distance to sides, circumcenter equal distance to vertices. I'm not sure what I said the first time.
You said
All right. Anyway, On this one. All right. Figure A, B, C, and D. So, medians come from which one of these figures? That's A. Altitudes are in angle bisector and perpendicular bisectors. Wait. Didn't you guys just say D? Or you guys said B? B. I heard you say D. D, B, it sounds very similar. Sorry. We good? Alright, next one. What point represents the following points of concurrency? So we had the points in here, Z, L, Q, and H. We had to put them in the correct place. Which one of those was the centroid? The circumcenter? The centroid. And, or the center? And that's it. Alright, on number 26. CZ is 14. So that means that, well, down here I could already put 14 down there because it was one of the things it asked for. And then CT, it also asked for, well, if this is 14, this is half of that, so that's 7. The whole thing would then be 21. All right? RZ, that's 6. So then ZA is 12. RA would be those two added together, so that's 18. BS, where's BS? BS is the whole thing, 36. So then a third of this is 12. And the 2/3 would be 24. So BZ, 24. Then they told us that CR is 20. Therefore, these two pieces have to be congruent, so this would also be 20. CA, which is this entire side here, is 28. So then CS would have to be half of that, which would be 14. AT, this one was a hard one. They gave us AT and BT. They said this is 3x. They said that this is x plus 42. You'd actually have to do a little bit of algebra there. 3x equals x plus 42. Bring the x over, divide by 2, and you get 21. So AT, put 21 back in. 21 plus 42 is 63. All right. Last question. BE is 8. So BE is 8. So EC is also 8. CH is 10. So then HA would also be 10. Right? All of those distances to vertices are the same. BA, this one, is 18. Therefore, these would be 9. The one that's a little tricky here, and I'm not asking you to do it on the test, this one, you have a right triangle. Pythagorean theorem. This missing side would be 6. Again, I'm not asking you to do Pythagorean theorem on the test at all. It's in our next section. So, we'll see plenty of it coming up very soon.
What?